cosmology is terrifying. It raises questions. It makes vivid questions that we all have about, what are we doing here? Right?
Yes.
So I try, and I think this goes all the way back to me really being into Carl Sagan. He always used to try this. You try to link it to things that people think about naturally. And that's why people are fascinated by this stuff, because they do actually think about it. It might not be with the right names or the right words or the right facts even, but they're thinking about, how did I get here? How did I come to exist? What is the future? Do we have a future? What was our past? These are universal questions, I think.
How are black holes formed?
They're formed at the end of stars' lives, or at least the smaller ones are. So what happens when a star is burning its fuel, like the sun is now? What's happening is that the sun is carrying out nuclear reactions in the core. They're called nuclear fusion reactions. That releases energy and that keeps the star up. But the star is burning a lot of fuel. The sun is burning 500 or 600 million tons of fuel every second. Hydrogen fuel can burn it into helium. So that can't go on forever. In the sun's case, it'll last for about another 4 or 5 billion years. When it runs out of fuel, then gravity will take over and the star will start to collapse. And if the star's big enough, there's no known force, even the rigidity of matter, that will stop it collapsing. So it collapses and collapses and collapses and forms a black hole. There are black holes, supermassive black holes at the centre of galaxies, and we don't fully understand how those form, but they're millions of times the mass of a star. So the Milky Way galaxy's got one. How they form and how galaxies formed in the early universes is a piece of research that's going on now. So if you remember those amazing, the Gargantua, the black hole in Interstellar, that's a simulation. It's not an artist's impression. It's a simulation of what Einstein's theory tells us a black hole will look like. And so I can use that to talk about what happens when you fall into a black hole. What would you see watching someone fall in? And you can explain all that using Einstein's theory. The idea that it's kind of a well-known idea, it's a bizarre idea that if I was to fall into a black hole and you were watching, you'd never see me fall in. You'd see time slow down. My time slow down as you watch me. So in the end, I'd just slow down and slow down and slow down, and then I'd get frozen on the event horizon and just fade away as an image, a reddening image on the event horizon. So time passes at different rates as you move close to the black hole and far away, because space and time are distorted by the mass of the black hole.
What is the most likely way that the world could end?
The Earth will end, ultimately, is as a cinder, because what's going to happen is that the sun, it'll grow as it gets older, and it'll swell up. It probably won't engulf the Earth, but it'll get close. The Earth will probably drift out because the sun will lose some mass. The Earth will end up toasted as a cinder, probably still orbiting the remains of the sun, which will be what's called a white dwarf star, which is just something that basically fades away. So that's what's going to happen in about 5 billion years. If you mean by the end of the world, you mean the end of civilization. But long before that, we'll have had to escape because the conditions on the planet will not support complex life like us. It'll be too hot.